We're going to start this class with a review of some pretty basic concepts: integers, fractions, and decimals. We're going to use integers, fractions, and decimals in basically every math class you take from here on out. So if you want to succeed in math, you have to be really solid with these three concepts first. Let's do a really brief review, starting with integers. Now, every tick on this number line is an integer. The integers are made up of the counting numbers, that's 1, 2, 3, 4, 5, 6, and so on. The negative counting numbers, that's the negative 1, 2, 3, 4, 5, 6, and so on, and 0. And very, very frequently in math classes, we want to combine integers by adding, subtracting, multiplying, and dividing. Let's do the very basics first. 4 plus 7 should be an easy one. But how would we see this on a number line? Well, if we started at 4, right here on the number line, because we're adding 7, we would actually go to the right 7 units, and we'd get to 11. Simple enough, hopefully. Okay, what about 4 minus 7? Well, we're still starting at 4, except we're subtracting 7. And what subtraction on the number line is moving to the left. If we move to the left 7 units, we get negative 3. Now, a lot of people think of integers as money. Anytime you have a positive integer, that's money in your pocket. And anytime you have a negative integer, that's a debt or an amount of money that somebody's taking from you. So if you have $4 and someone is taking $7 from you, you're left with negative $3. You're left with $3 of debt. Okay, let's run through the last two and then we'll talk a little bit more about these. If we start at negative 4 and we're adding 7, 1, 2, 3, 4, 5, 6, 7, we get to positive 3. And if we start at negative 4 and we subtract 7, that's moving left, we get to negative 11. Now, every one of these numbers over here has a sign attached to it, and that sign is directly to its left. So this is a positive 4, a positive 7, positive 4, a negative 7, a negative 4, a positive 7, negative 4, negative 7. And there's no reason why we couldn't write 4 minus 7 in a slightly different way. We could switch the numbers around, but keep the signs on the appropriate number. So we could write this negative 7 plus 4. That negative belongs to the 7, the positive belongs to the 4. And again, this would be the same answer, negative 3. The same is true here. Negative 4 plus 7 could also be written with the numbers switched around. We have to keep the signs where they are. The negative belongs to the 4 and the positive belongs to the 7. So 7 minus 4 is going to be 3. So as you can see, there's often more than one way to express the same thing. Let's add a few more problems into the mix here and remind ourselves what happens when you subtract a negative. Well, subtracting a negative is like taking away debt, which is the same as adding money, if that makes sense. So anytime you're subtracting a negative number, you can immediately switch that to a plus. And we're going to do that with the next couple of lines here too. Instead of 4 minus negative 7, we can just write that as 4 plus 7. Minus a negative 4 can also be written as a positive 4. Then we just copy the rest of the problem down. Minus a negative 4, again, could be written as just a positive 4, and then you have to copy down the rest of the problem. Now we've gotten these 4 problems down to problems that we had done before up here. Negative 4 plus 7, we realized before was 3. 4 plus 7 is 11, and 4 minus 7 is negative. We also need to know how to multiply and divide integers, and we often do multiplication of integers by putting them in parentheses and just placing them right next to each other. So 4 times 7 is 28, of course. Now, negative 4 times 7 is going to be negative 28. 4 times negative 7 is also going to be negative 28. And negative 4 times negative 7, anytime you multiply two negative numbers, you get a positive number. Positive 28. So notice the pattern in multiplication. If you have one negative sign, the answer turns out to be negative. If you have two negative signs, the answer turns out to be positive. Now, if you had 3 negative signs, the pattern continues and you do end up with another negative number. That would be negative 56. If you had 4 negative numbers multiplied by each other, that would make a positive. And that pattern continues. Now the same pattern is true of division. I'll write this out the long way. 4 divided by 7, we usually just write as 4 sevenths. Negative 4 divided by 7 is negative 4 sevenths. 4 divided by negative 7, again, is negative 4 sevenths. And negative 4 divided by negative 7 is positive 4 sevenths. Same pattern there. If you're dividing and there's one negative number, your answer will turn out to be negative. If you're dividing and there are 2 negative numbers, your answer will turn out to be positive, and so on. Now this last bit reminds me that there are things called fractions that we need to know how to deal with. So let's move on to fractions. Now when we start talking about fractions, one of the first things that comes up is a common denominator. And I want to remind you that you need a common denominator when you are adding or subtracting fractions. And now you don't need a common denominator when you're multiplying or dividing fractions. Okay, let's see what that actually means. Let's add 1/2, leave a lot of room, plus 1/3. Now, most of arithmetic can be broken down into sticks, stones, and pizza. And in this case, if we're talking about fractions, we can think of that as pizza. So what we're trying to do here is add 1/2 and 1/3. If we have 1/2 of a pizza and 1/3 of a pizza, how much pizza do we have combined? And to be honest, you really don't know. It looks to me like you have a little bit less than one pizza, but exactly how much, I'm not really sure. So what you actually have to do is you'd have to divide these two pizzas into equal numbers of slices. So if we divide each pizza into, in this case, 6 slices, each one of these slices in these two pizzas is exactly the same size, if I had drawn it well. You'll notice that each pizza is divided into sixths. Each one has 6 slices. The half pizza is 3/6 slices, and the third pizza is 2/6 slices. If you add those 3/6 and those 2/6 together, you're going to get 5/6 of a pizza. Now, how do we actually do that mathematically is the important part. Well, what we do is we rewrite this 1/2, not as a half fraction, but as a 6th fraction. And the way that we do that is we multiply by this factor of 1. This 3/3 is technically just a 1. So we're allowed to multiply a fraction by, say, 3/3. If we multiply these fractions out, that's 1 times 3, 2 times 3, that's going to be 3/6. And basically what we've done is we've said that this 1/2 of a pizza is the same thing as 3/6 of a pizza, as we discovered earlier. Now, if we do the same thing to this pizza here, we want our denominator to be a 6, so we multiply it by 2/2. Again, this is a factor of 1, so we're allowed to do that. Multiply across the numerator and across the denominator, and you get 2/6. So we discovered mathematically what we did by splitting up the pizza into 6 slices. We had 3 slices in the 1/2 pizza and 2 slices in the 1/3 pizza. Now that we have that common denominator, we can combine to 5 slices out of a 6-slice pizza. So what did we just discover? We just discovered that 1/2 plus 1/3 is 5/6. Notice while doing this adding fractions example, we actually ended up multiplying fractions right in the middle. So we reminded ourselves that to multiply fractions, we just multiply straight across the numerator and straight across the denominator. Okay, let's try one where we subtract fractions. I'm going to leave a lot of room again here, and I want to do 4/7 minus 1/3. Okay, we want the denominators to be the same in these two fractions. And to do that, we need to multiply the first fraction by 3/3 and the second fraction by 7/7. If we multiply straight across the numerator and straight across the denominator, we get 12/21 for our first fraction and 7/21 for our second fraction. Now that we have a common denominator, we are allowed to combine these two fractions into one just by subtracting. 12 minus 7 is 5, and we keep the denominator exactly as it is. We just learned that 4/7 minus 1/3 is equal to 5/21. Just really quickly, in case it wasn't clear, let's multiply a couple of fractions. 4/7 times 2/3. We do not need a common denominator. We just multiply straight across the numerator and straight across the denominator to get our answer. Again, we only need a common denominator when adding and subtracting fractions. And if we're dividing fractions, there is a trick. You copy down the first fraction, you multiply, and you flip over the second fraction. A lot of people call this copy.flip or copy.flop. Now it's a multiplication problem after you've flopped the second fraction, and you multiply straight across. That's 12 in the numerator, that's 14 in the denominator. Oh, and here's our little mini lesson on reducing fractions. These are both even numbers, I'm noticing, so we can divide each one by a factor of 2. Divide the numerator by 2 and you get 6. Divide the denominator by 2 and you get 7. So we just found that 4/7 divided by 2/3 is 6/7 after we reduce. Now, one more thing about dividing fractions. 4/7 divided by 2/3 could have also been written as a complex fraction, sort of 4/7 divided by 2/3, just like that. And honestly, that's a little bit more common in math than writing it with the division sign. And you would get, again, 12/14, which you reduce to 6/7. Okay, one more quick topic, very quickly. We do have to deal with decimals occasionally in this class. Integers and fractions are much more common than decimals in our math classes. So I just want to remind you that if you had something like 5.2 and you multiplied it by 10, that would move the decimal place over to the right and you would get 52. If you had something like 5.2 and you divided by 10, that would move your decimal place to the left and you would end up with 0.52. We could keep going with this. If you had something like 5.2 and you multiplied by 100, that's 2 factors of 10. That's going to move your decimal place to the right twice. If you had something like 5.2 and you divided by 100, that's 2 factors of 10. That's going to move your decimal place to the left twice. So moving your decimal place to the right and to the left is just about multiplying and dividing by factors of 10. That's what I want you to remember for this class. If we need any more work with decimals, we'll do it throughout the class. I don't know that we will. So I'm going to stop the video right there. Make sure that you fill out the worksheet and answer all the questions that go along with this video and hand it in to class, and I'll see you there.